Dear students, we are handling the chapter Quadratic Expressions Objective Level 2 classwork. Quadratic Expressions Objective Level 2 classwork. In previous class, you have completed 40 questions. Of course, 38, 39, 40 questions in synopsis only we have discussed. In previous class, we have discussed 37 questions. Until 37 questions we have completed. So let us going to discuss from 41 question onwards today. Level 2 classwork, 41 question. If the difference between the roots of the equation x square plus ax plus 1 equal to 0 is less than root 5, then the set of possible values of a given quadratic equation is x square plus ax plus 1 is equal to 0. Given the condition that difference between, so modulus of alpha minus beta is difference between the roots, that is less than root 5 and possible values of a. We can use the formula modulus of alpha minus beta is equal to b square minus 4ac whole by mod a, root of b square minus 4ac whole by mod a. So here we can write b square minus 4ac means a square minus 4 by 1 less than, this is over root, less than root 5. By squaring both sides we can write a square minus 9 less than 0. This can be written as a plus 3 into a minus 3 less than 0. Therefore, a belongs to minus 3 comma 3. This is the interval. A lies between this interval. Now, 42nd question. The greatest negative integer satisfying the two quadratic inequalities x square plus 4x minus 77 less than 0 and x square greater than 4. Greatest negative integer is discussing about greatest negative integer such that x square plus 4x minus 77 less than 0 comma x square greater than 4, x square greater than 4. So x square, here we can write x square plus 11x minus 7x minus 77 less than 0 comma x square minus 4 greater than 0. X taken common, it becomes x plus 11 minus 7 taken common, it becomes x plus 11 less than 0. Therefore, we can write x plus 11 into x minus 7 less than 0. X plus 11 into x minus 7 less than 0. This one we can write as x plus 2 into x minus 2 less greater than 0. So depends upon these two values, we can write x belongs to minus 11 comma 7 and x does not belongs to minus 2 comma 2 closed interval. So x belongs to minus 11 comma 7. Here x less than minus 2 comma x greater than 2. Depends upon these two values, we can take a common domain. Common domain as here minus 11, this is minus 2 and this is 7, this is 2, this is 7. Minus 11 comma 7, we bracket like this and minus 2 less than minus 2 concept. Yeah, and greater than 2 concept. So this and this are common domain, minus less than minus 2, like this. So this is a common and this is a common. This is common domain, yes, this is common domain. That is equal to common domain is equal to minus 11 comma minus 2 union 2 comma 7. He is discussing about only greatest negative integer. So 2 comma 7 is not considerable for negative integers. According to option, the value negative integer should lie between minus 11 and minus 2. So, question number 42, minus 1 is greater than minus 2, so it is not minus 2 should not be, so minus 3 is the correct option. Option 3, that is equal to x less than minus 3 is equal to simply like x is equal to minus 3. Minus 3 satisfies for this value. 43rd question, the solution set contained in R. The solution set contained in real number of the equation 3 power x plus 3 power x plus 3 power 1 minus x minus 4 less than 0. 3 power x plus 3 by 3 power x minus 4 less than 0. You can write 3 power x whole square minus 4 into 3 power x plus 3 less than 0. Let 3 power x is equal to y. So, y square minus 4y less than y square minus 4y plus 3 less than 0 we can write. Y square minus 4y plus 3 we can write y minus 1 into y minus 3 less than 0. Y belongs to 1 comma 3. Here y belongs to 1 comma 3 means 3 power x belongs to 1 comma 3. We can understand as 3 power x belongs to 3 power 0 comma 3 power 1. So x belongs to open interval 0 comma 1. It is the correct answer. Now 44th question. If the equation ax square plus 2bx minus 3 is equal to 0 has non-real roots, given quadratic equation ax square plus 2bx, ax square plus 2bx plus minus 3 is equal to 0 has non-real roots. When a quadratic equation has a non-real roots, we can apply delta less than 0. So, whenever delta less than 0, you can write here non-real roots delta less than 0. So 4b square minus of minus plus 12ac less than 0. b square plus 3ac less than 0. I think no need this one. Okay, next one we given also 3c by 4 less than a plus b. Also given 3c by 4 less than a plus b. Use this one 3c less than 4a plus 4b. That implies 4a plus 4b minus 3c greater than 0. Because 4a plus 4b greater than 3c. Okay, you can understand this one. Putting here 2, it becomes 4a plus 4b minus 3c. That implies 1 unit. From 1 I am writing. From 1 we can conclude that f of 2 greater than 0. F of 2 greater than 0. Here you can understand that implies ax square once you can see the question condition. 3c by 4 less than a plus b. It is having a non-real complex roots. Whenever the quadratic equation is greater than 0, f of x, let us think as that implies you can write f of x greater than 0. Whenever f of x greater than 0, co-f of x square, comma, expression have same sign. Expression have same sign. Co-f of x square comma expression have same sign for all x belongs to R when delta less than 0. Here we had written, we got given that delta less than 0, so it is true for all real values. That is not only f of 2 students, f of 0 also greater than 0, because a is positive. Of course, he did not discuss about a. Whenever he is not going to discussing about a belongs to r plus r, q plus or anything, you should consider as it is plus value only, because we got f of x is equal to 0. Not only f of 2, this is the hint we got. Simply whenever you have substituted 2, the expression became positive. Whenever you have substituted 2, the expression became positive. Then you can understand whenever you are substituting any number, the expression becomes positive. So f of 0 also greater than 0. Now substitute here instead of x, put 0 here, 0 plus 0 minus 3c. So you can understand minus 3c greater than 0 divided by minus 3. You can write minus c greater than 0. So it becomes c less than 0. C less than 0 is the correct option. Correct option is first option. Now 45th question. 45th question. Cos p minus 1 into x square. Cos p minus 1. This is the coefficient of x square. Plus cos p into x. Cos p minus 1 into x square plus cos p into x plus sin p equal to 0. In the variable x has real roots, then p can take any value in the given interval. Given that it has real roots, whenever the quadratic equation has real roots, condition you can use delta greater than equal to 0 because the expression having real roots. So cos square p minus 4 into cos p minus 1 into sin p greater than equal to 0. You can understand this one. Put here 1 minus sin square p. 1 minus sin square p minus 4 sin p cos p plus sin p greater than equal to 0. So sin square p method. Write like this: sin square p minus sin p. Sin square p minus sin p plus 4 sin p cos p plus 4 sin p cos p minus 1 less than or equal to 0. Sin square p, students, this one less than or equal to 0 means this is minus 1, this is minus 1, this should be positive, this should be positive. So it should be positive. Whenever it is sin p is positive, then only the expression becomes positive. Whenever it is positive, it becomes negative. So here condition is, we can write, condition is sin p should be positive. Sin p should be positive. That implies we know that sin p belongs to 0, 5. So p belongs to, because in first quadrant and second quadrant sin p is positive. If sin p is positive, of course it is negative also, no problem. Here it becomes plus. You should get here less than the value. So whenever it is positive, then only it is negative. Minus, of course it is negative. Whenever it is positive, cos becomes negative or positive. So doesn't matter about this value. So you can understand sin p is absolutely positive. Whenever sin p is positive, first quadrant, second quadrant, you know. That is why you can add the option 4. Now 46th question. A and B are the roots of the equation x square plus ax plus b equal to 0. Then least value of x square plus ax plus b, x belongs to R. Given quadratic expression, we can write as x square plus ax plus b equal to 0. For this one, for this quadratic equation, a comma b are roots. can understand sum of roots a plus b is equal to minus a and product of roots ab is equal to b. Therefore, a is equal to 1. Substitute here 1 plus b is equal to minus 1. Therefore, b is equal to minus 2. Depends upon this quadratic equation x square minus 2x plus 1 is equal to 0. For this quadratic equation, minimum value. For this quadratic equation, minimum value formula 4ac minus b square by 4a. Whenever a greater than 0, it has only minimum value. Apply the minimum value concept, it becomes 4 into 1 into 1, 4 minus 4. 4 plus 4, 8 by 4, 2. Maybe somewhere wrong option is not there. X square plus ax plus b. Whenever the roots are b not equal to 0, he given product of roots equal to x square plus ax plus b. A plus b is equal to minus a and a is equal to 1. 1 plus b is equal to minus 1, b is equal to minus 2. Wrong, this one wrong. A value 1 x square plus b plus x. X square plus x minus 2 is equal to 0. Now apply 4ac, 4 into minus 2, minus 8, minus 4, minus 9 by 4. Second option. Let us see 47 question. If x square plus 1 by x square equal to a and x minus 1 by x equal to b, x square minus 1 by x, no, x square plus 1 by x square equal to a comma x minus 1 by x is equal to b, mod x greater than 1, then value of a by b, the value of a by b mod x greater than 1, that is the condition. Now b square I am writing, b square is equal to x square plus 1 by x square minus 2, that implies you can understand b is equal to a minus 2, that implies now a is equal to b plus 2. Now we can write the value of a by b. A by b is equal to b plus 2 by b. B plus 2 by b you can understand 1 plus 2 by b. B plus 2. A meaning itself is x square plus 1 by x square minus 2, correct. B is equal to, this is a minus 2, taken this side, b plus 2 is equal to, yeah, correct. B plus 2 is equal to a, now a by b means b plus 2 by b. So it becomes 1 plus 2 by b. Now a by b value using am greater than equal to bm concept. Let us verify a plus b by b. A by b only is asking. A value we got b plus 2. This is 1 plus 2 by b we got. Now use b by b plus 2 by b. Use am greater than or equal to gm. For two numbers, 1 plus 2 by b whole by 2 greater than or equal to root of 1 into 2 by b. So greater than 2 by b, 2 by b is wrong. Somewhere mistake is there. What is 7th question? B plus 2 by b, a by b we should calculate. Once again I can do. X square plus 1 by x is equal to a and x minus 1 by x is equal to b. X minus 1 by x whole square is equal to b square. So we did wrong here. X minus 1 by x whole square is equal to b square. So x square plus 1 by x square minus 2 is equal to b square. I written wrong there b. You can understand minus a minus 2 is equal to b square. So a is equal to b square plus 2. Now A by B is equal to B square plus 2 by B. You can write this one as B plus 2 by B. Okay. Now using AM greater than or equal to GM concept. So B plus 2 by B are two terms. B plus 2 by B greater than or equal to root of B into 2 by B. It is correct. Now B get cancelled. So B plus 2 by B greater than or equal to 2 into this is root 2. 2 root 2 is the minimum value. 47, fourth option. Now 48th question. If alpha comma beta are the roots of x square minus of a minus 2 into x QE x square minus of a minus 2 into x quadratic equation x square minus of a minus 2 into x minus of a plus 1 minus of a plus 1 is equal to 0 where a comma b a is variable, then least value of alpha square plus beta square least value of alpha square plus beta square. So first of all we can understand alpha square plus beta square is equal to alpha plus beta whole square minus 2 alpha beta. So using the sum of roots and product of roots concept, alpha plus beta is a minus 2 whole square minus 2 into a plus 1, that is equal to a square minus 4a plus 4 minus 2a minus 2. So alpha square plus beta square we are getting as a square minus 6a plus 2. For this one, min maximum value apply it like this. Min value or max value. Min value only whenever a greater than 0. I am writing like this formula 4ac minus b square by 4a. We can use it. 4 into a means 1, c means 2. 4 into 2 minus b square means 36 whole by 4. 4 to the 8. 8 minus 36 minus 28 by 4. Fourth table minus 4a. 5 we given. Maybe once again verify. 4ac 4 into 1 into 2. 8 minus b square 6a. 8 minus 36 exactly minus 28. Let us verify once again. Alpha beta are the roots. A minus 2 x square minus of a minus 2. This is minus 2 alpha, so it becomes plus alpha plus beta whole square. So 2a plus 2 a square minus 2a plus 6 4ac 4 into 6 24 minus this is 4 4 6 are 24 minus 4 becomes 20. 20 by 4 you can write as 5. So 5 is the minimum value. Now we are entering into modulus function. The modulus function depends upon critical points concept. The minimum value of 49th question. The minimum value of modulus of x plus modulus of x plus 1 by 2 plus modulus of x minus 3 plus modulus of x minus 5 by 2. For this type of functions, we should calculate critical points. Critical points meaning is that we should equate the variable values to 0, or it is called as zeroth polynomial. So critical points is equal to here 0, comma, minus 1 by 2, comma 3. I can say that you can understand this 0. Whenever you put the value, what the value becomes 0. Here, if you put 3, it becomes 0 like that. Not for all, separately, for separating critical point, you should write 0, comma, minus 1 by 2, comma, 3, comma, 5. Now, whenever you are thinking this is as f of x, if you substitute the value, whatever the critical points we got, substitute all values in the given f of x, where the minimum value you are getting, that is the minimum value. Where means if whenever where you are putting or substituting the value in the function, f of 0 you put first of all. So it is 0, 0 plus 1 by 2, 1 by 2. Students, try to understand, you can understand this one taking absolute value. 1 by 2 plus 3 plus 5 by 2. Even though it is minus, you should consider absolute value, that is modulus. 5 plus 1, 6 by 2, 3 plus 3, 6, keep aside. And next one, f of minus 1 by 2. F of minus 1 by 2 substitute here. It becomes 1 by 2, that becomes 0, 1 by 2. Students, minus 1 by 2, minus 3, minus 1, minus 6, minus 7 by 2. So it is 7 by 2. 7 by 2. 1 by 2, minus 5 by 2. 1 minus 5, minus 4 by 2. Right like this, 4 by 2. 7, 4, 11, 1, 12 by 2, 6. It's a keep aside. Like this you should do. F of 3, substitute here. 3 plus 2, 3 are 6 plus 7. This is 7 by 2. 3 plus 7 by 2 and 3 minus 3 becomes 0. 3 minus 5 by 2 plus 6 minus 5, 1 by 2. So 7 plus 1, 8 by 2, 4 plus 3, 7. Next, f of 5 by 2. Substitute here 5 by 2. And 5 by 2 plus 1 by 2 becomes 6 by 2. And 5 minus 3 becomes 2. Now 5, 6, 11, 11 by 2. 5 plus 5 plus 1 by 2. 5 is 10 plus 11. 5 by 2. 5 by 2 plus 1 by 2. It is 3. It's okay. Next it is 0. 5 by 2 plus 5 plus 1 by 2. We miss it. 5 plus 1 by 2. 2 5 is 10. 10 plus 1, 11 by 2. 11 by 2 plus 5 minus 5 by 2 minus 3. 5 minus 6. So it is 1 by 2. 5 11. 16 1 17 by 2. 5 by 2 plus 5 plus 1 6 by 2. 5 minus 3 2. 5 by 2 plus 1 by 2 6 by 2. First 5 by 2. 5 6 11 by 2. 5 by 2 minus 3. It is not. 5 by 2 minus 3 becomes 5 minus 6. So it is 1 by 2. 11 by 11 plus 1. 12 by 2 6. So minimum value is 6. Anything you can take. We got 3 times. Maximum value is 0. Minimum value is equal to 6. Now 50th question. Sum of roots of equation. It is also a mains concept. This one. All are mains questions. Sum of roots. Sum of roots of x minus 2 whole square minus 2 into modulus of x minus 2 minus 15 equal to 0. Sum of roots of x minus 2 whole square minus 2 into modulus of x minus 2 minus 15 equal to 0. It is IMP concept because some depth is there in sum. Put modulus of x minus 2 is equal to that. We know that every square is positive. X modulus of x minus 2 is equal to y. You can understand here. This is also modulus of x minus 2. Of course, you put mod or not. You no need to put modulus because anyhow it is square. It is positive. You can write now y square minus 2y minus 15 is equal to 0. Let us consider the factors. Y square minus 5y plus 3y minus 15 is equal to 0. Taking common y minus 5 plus 3 you can take common, plus 3 into y minus 5 equal to 0. So y is equal to minus 3 comma y is equal to 5. Here we are observing about the modulus of x minus 2. It is a positive absolute value. Whenever modulus of x minus 2 we thought as y, negative should not consider. No need to consider negative value. So y is equal to 5 is confirmed here. That implies x minus mod x minus 2 is equal to 5. Of course, for modulus x minus 2 here, if we are eliminating modulus, you can write x minus 2 is equal to plus or minus 5. So x minus 2 is equal to 5 is the first case and x minus 2 is equal to minus 5 is second case. So x is equal to 7 comma x is equal to minus 3. Now sum of roots. Students, for the quadratic equation depends upon modulus value. We got 3 roots. The 3 roots are here 7 and minus 3. We should not consider here. That is the main point here. Now sum of these 3 roots. Sum of the roots is equal to 7 minus 7 plus of minus 3 becomes 7 minus 3. That is 4. Is the correct answer. Now 51st question. The real roots. The real roots of the equation. The real roots. The real roots of equation modulus of x square plus 4x plus 3. Modulus of x square plus 4x plus 3 plus 2x plus 5. This is also most IMP conceptual question in the mains concept. Modulus of x square plus 4x plus 3 plus 2x plus 5. We should calculate real roots. For modulus value, we know that the theory I am writing here, modulus of x is equal to x. If x is greater than or equal to 0, that modulus of x is equal to minus x. If x less than 0, for modulus of x square plus 4x plus 3 is equal to, you can write x square plus 4x plus 3 when x square plus 4x plus 3 greater than 0. Try to understand, this is the whole part. Next one, for modulus of 4x plus 3 is equal to minus x square minus 4x minus 3 when x square plus 4x plus 3 less than 0. Like this you should write. Now case 1 only. Case 1. Consider as x square plus 4x plus 3 greater than 0. Okay, greater than 0. Now we know that the roots x plus 3 into x plus 1 greater than 0. So that implies x does not belongs to minus 3 comma minus 1. It's okay. That implies x less than minus 3 comma x greater than minus 1. Keep aside. Now I am writing f of x. Taking this root as the modulus as positive. Now you can write x square plus 4x plus 3 plus 2x plus 5. That is equal to x square plus 6x plus 8. Put is equal to 0. He given is equal to 0. So it is not expression, it is equation. Now root is equal to 0. Is equal to 0. We can write here x plus 2 into x plus 4. X plus 2 into x plus 4 equal to 0. You can understand here x is equal to minus 4 comma x is equal to minus 2. Students, here you should observe the thing that it depends upon it means the values of x depends upon the concept of the modulus. We have taken case 1 modulus as a positive. So x less than minus 3 and x greater than minus 1 values only we should calculate. X less than minus 3 means minus 4 less than minus 3. So it is correct. It is right. You should consider. X is equal to minus 2. It is minus 2 is not at all greater than minus 1 and minus 2 is not at all less than minus 3. This is no. Depends upon this link up. This is not possible. So x is equal to minus 4 we got as a value. Next one. Case 2 I am writing. Case 2. Case 2 means take this one. X square plus 4x plus 3 less than 0. So you can understand x plus 3 into x minus 1 plus x plus 1 less than 0. That implies x belongs to minus 3 comma minus 1. The value whatever we are considering, the value should lie between minus 3 and minus 1. Now I am writing about f of x. F of x is equal to, write like this, minus x square, take it negative, minus x square minus 4x minus 3 plus 2x plus 5 is equal to 0. That implies minus x square minus 2x minus x square minus 2x plus 2 is equal to 0. By multiplying with minus both sides, it becomes x square plus 2x minus 2 equal to 0. I think there is no factors. Depends upon the formula minus b plus r minus root b square minus 4ac by 2a. So x is equal to minus 2 plus r minus 2 root 3 whole by 12. Minus 1 plus r minus root 3. Oh, sorry, whole by 2 is okay. Now x is equal to minus 1 minus root 3 is a root and x is equal to minus 1 plus root 3 is a root. Root 3 value is 1.732. 1.732 minus 1 becomes 0.732. Here x is equal to this becomes minus 2.732 and this becomes x is equal to 0.732. According to our condition, x belongs to minus 3 and minus 1. So 0.732 you should not consider. No, this is correct. This is right. Therefore, roots are, we can write now, roots are minus 4 comma minus 1 minus root 3 are correct answers. This is the most IMP question in advanced concept also, because the modulus concept is important. The modulus concept is most important in integration, different integration concept also. You should not forget, students. Remember as the formula also. Now 52nd question. 51 question completed. 52nd question also modulus concept. Second question. X satisfies modulus of x minus 1 plus modulus of x minus 2 plus modulus of x minus 3 greater than or equal to 6. X satisfies. Then that implies, according to option, what option is correct? Which option is correct? Now, by taking absolute value and depends upon the modulus concept, we can understand here. By critical points, first of all we can write 1, 2, 3. Critical points is equal to 1, 2, 3. I think in limits concept or continuous concept we have discussed about whenever 1, 2, 3 numbers are there, one left of one, right of one, left of two, right of two, left of three, right of three, like that we have observed. So here the cases are cases x less than 1, x greater than 1, x less than 2, x greater than 2, x less than 3, x greater than 3. That is, the concept is x less than 1 means the neighborhood. 0 less than x less than 1. X greater than 1 means 1 plus 2 minus 1 less than x less than 2. Next, x greater than x less than 2 completed, and x greater than 1. The both concepts are like this only, and x greater than 2, so 2 less than x less than 3, and x greater than 3. Like that, the concepts 1, 2, 3, 4 concepts now should be defined. Case 1, x less than 1. So between 0 and 1, substitute here. Whenever x less than 1, let us consider 0.5 like that. 0.5 minus 1 becomes minus 0.5. So absolute value becomes 1 minus x like this. We should consider as negative value. For this one also 2 minus x. Because all are negative. 2 minus x. 1 x less than 1 absolutely negative, and this is also negative. 3 minus x greater than or equal to 6, right? 1, 2, 3, 6. 6 minus 3x greater than or equal to 6. That implies minus 3x greater than or equal to 0. You can understand x less than or equal to 0. Keep it side. Next, case 2. Case 2. 1 less than x less than 2. Between 1 and 2, first one becomes modulus x minus 1 becomes positive. Simply leave the x. It becomes 2 minus x, because 1.5 minus 2 minus 1.5 minus 3 is also minus 1 minus x minus 1 plus 2 minus x plus 3 minus x. It is also negative, greater than equal to 6. X and x will be getting cancelled. 3 to 5, 5 minus 1, 4 minus 4. No, 4. 4 minus x greater than or equal to 6. Now 4 minus 6 taken this side, 4 minus 6 minus 2 minus x greater than or equal to 0. Then x plus 2 less than or equal to 0. X less than or equal to minus 2. So keep aside. Now case 3. 2 less than x less than 3. So first becomes positive x minus 1 plus next 2 becomes also positive x minus 2, next becomes negative 3 minus x greater than or equal to 6. Here plus x minus x will be getting cancelled. 3 minus 3 also got cancelled. So x greater than or equal to 6 we got. Keep it side. Next case 4. X greater than 3. So everything is positive. Whenever x greater than 3, everything is positive. X minus 1 plus x minus 2 plus x minus 3 greater than or equal to 6. You can write 3x minus 3, 1, 2, 3, 3, 6, 6 plus 6, 12. 3x greater than or equal to 12, x greater than or equal to 4. Now, common domain I can write. By taking real line, common domain. Draw a real line. Write the values whatever we got. First 0, minus 2, put here minus 2, 0, and put here 4, and put here 6. X less than minus 2, that's the very equal to like this. And x less than equal to, it's okay, but it is correct. And x greater than 3. 3 is also, of course, 4. And like this. So for this one it is correct. Whenever x greater than 4, x greater than 6. So 4 should be. Now According to option, this is x less than or equal to 2 comma x greater than or equal to 4. Let us verify. Yeah, x less than or equal to 0. So minus 2 is there. This is also correct. X less than or equal to 0 comma x greater than or equal to 4. Or minus 2. 52, third option. Yes, it is correct. Now, 53rd question. Before going to 53rd question, we should discuss about the De Moivre's theorem concept. Let us write concept of De Moivre's theorem. In complex numbers chapter, you are having De Moivre's theorem. Cos theta plus I sin theta. Cos theta plus I sin theta whole power n is equal to cos n theta plus I sin n theta. And cos theta minus I sin theta whole power n is equal to cos n theta minus I sin n theta. Students, I will say proof also in that chapter. Complex number and De Moivre theorem, 2 chapters are there before quadratic expression chapter in 28 IBE. So you will see the proof there. Now let us remember as formula cos theta plus I sin theta whole power n. Now 53. A is equal to cos 2 pi by 7 plus I sin 2 pi by 7. Alpha is equal to a plus a square plus a power 4 plus a, that's all. Beta is equal to a cube plus a power 5 plus a power 6. Then alpha comma beta are the roots of the equation. Once upon a time, this is most IMP question in MSET. Most IMP question in MSET. Cos 2 pi by 7 plus I sin 2 pi by 7. Now, a power 7n. A power 7 is equal to cos 2 pi by 7 plus I sin 2 pi by 7 whole power 7. Just depends upon the De Moivre theorem concept. It can be understood cos 2 pi cos n theta plus I sin n theta. So whatever the power n is there, it becomes in numerator, just in the fraction. Cos 2 pi by 7 into cos 2 pi by 7 by 7, I sin 2 pi by 7, 2 pi into 7 by 7 like this. So it becomes cos 2 pi plus I sin 2 pi. Cos 2 pi value 1. Sin n pi equal to 0, we know that 1 plus I into 0, that is equal to 1. Therefore, a power 7 is equal to 1. This is the most IMP useful for us. Cos 2 pi means cos 360. Of course, it is cos 0, it is 1. A power 7 is equal to 1. Let us remember as a power 8 becomes a because multiply a with both sides. In the concept, a power 9 is equal to a square. In the concept, a power 10 is equal to a, like that. A power 11 equal to a power 4, like that. That's all. Now, required QA and required quadratic equation. We know that x square minus x into alpha plus beta plus alpha beta equal to 0. That implies x square minus x into alpha plus beta, write in proper way students. A plus a square plus, that is a cube. A plus a square plus a cube plus a power of 4 plus a power of 5 plus a power of 6 until there. Plus alpha beta means a plus a square plus a power of 4 into a cube plus a power of 5 plus a power of 6 is equal to 0. Now we can understand here x square minus x into, this is a geometric progression concept. Let us remember the geometric progression concept. Of course, now I am writing product of roots alpha beta in multiply students. A plus a cube becomes a power 4 like that. A power 4 plus a power 6 plus a power 7. Next with a square you multiply. A power 5 plus a power 7 plus a power 8 plus a power 7 plus a power 9 plus a power 10. Now 1, 2, 3. 3 a power 7s are there. We got a power 7 value as 1. Yes, here we put 1 plus 1 plus 1, 3. 3 plus, now, yes, I said here a power 8 means a power 9 means a square, a power 10 means a cube. So a power 4 plus a power 5 plus a power 6 keep aside. And instead of a power 8, you write a. Instead of a power 9, you write a square. Instead of a power 9, you write a power 10. That is